20s, Mr. Riley here. We are talking about paleontology, which is, kind of a cool thing. This is the only time in any high school course where you learn about these things, and some of them are pretty interesting. So we've talked about fossils, and some of the information that fossils can give us. They can give us, evidence of what past ecosystems were like. They can give us evidence of plate tectonics and continental drift. They can give us evidence of what past climates were like. So they're giving us all this evidence of things that existed and where they existed in the past. But the one missing piece is exactly how long ago did these organisms exist? So what we're looking at today is dating. So how do we figure out how old a rock or a fossil is? And when we look at dating things that are old, there's two schools of thought, and paleontologists will actually take both of these, combine them, and then come up with an estimate for how old something is. So the first school of thought is relative time. So when I say relative, I'm saying that something is older relative to something else. It's a comparison. And so for example, saying fossil B is older than fossil A. So that would be relative time. So that's one piece of the puzzle. But if I don't know how old fossil B is, then it only gives me one piece of information. The second part of this is measuring absolute time. And this is something where we're going to actually use a process, and we're going to be able to measure time in years. We use radioactive decay of elements to measure this, and this is something we're going to look at as well. But for now, we're going to look at relative dating, and there are 4 principles of relative dating that we're going to take a look at here. So the first principle of relative dating kind of seems like maybe the most common sense one, and that is the principle of superposition. And all that means is that rock layers that are older are deeper. So in this diagram right here, this would be the oldest layer, and layer A would be the youngest. And an example, like you throw laundry in the laundry hamper. The oldest laundry is at the bottom of the laundry hamper. The youngest is at the top. And so that's how that works. And that one's kind of common sense. The next thing, and we've talked about in plate tectonics, events that can occur. When two plates collide, we can have a shifting in the rock layers that make up the crust. And so the second principle is called original horizontality. And basically that means that due to gravity, when rock layers are developed, they get formed in horizontal layers. So if I see a rock layer like this, there was some kind of folding, tilting that occurred, and now I have layers they're not totally horizontal, but we know that originally they were horizontal. So if I'm looking at some rock and I say, let's say I find an object in layer B that is down here, and an object in layer A that's up here. Now, physically, when we're observing this, we see that the object in A is above the object in B. And using the law of superposition, we would say that the object in A is younger than the object in B. But we have to also apply this principle. And we have to say that if we look at the layers as a whole, we know that A was built first. It was originally underneath B. So any object that's in A at all would be older than an object that would be in B. Okay, so that's the second principle. The third principle is called lateral continuity. And basically all this means is I can have structures that are separated by space that were still built at the same time. And so this would be like this is the Grand Canyon, for example. And so this was all of this rock once existed, but it was eroded by water and, well, mostly water in the Grand Canyon, water, wind, whatever. And so if we look across, we can look across a gap, and we can assume that similar layers were built at the same time. And the last one is called cross-cutting. And what that means is, we talked about the structure of the Earth. In the mantle, there is a molten material, magma. And sometimes that magma can come up from the mantle into the crust and cut through those layers of rock. So anything that's any rock formation that cuts through multiple other rock formations is going to be younger or newer than the rock that it cut through, right? The rock had to originally be there to be cut through. So in this case, this is what we call an intrusion. So this is igneous rock, melted rock, that intrudes on the layers. Okay. So to review, we have the law of superposition, where the deepest is the oldest. We have the law of original horizontality. So I have to take the whole structure, the whole layer into account, because there could be some shifting that has occurred. The law of lateral continuity. So I may have some erosion that's occurred, but I still know that layer 4 is the same layer over here as it is over here. And then cross-cutting, where I have an igneous intrusion, some magma that's come up and cut through existing rock layers. Okay, this number 4 is actually a combination of looking at superposition and also looking at cross-cutting. So this layer 4 only cut through 1, 2, and 3, and then layer 5 was built on top of it. So that's what we're going to look at here. We're going to look at an example of combining all 4 of these, and I'm going to give you guys a little assignment for this as well. Combining all 4 of these and using some logic to figure out the relative ages of the rocks. So what's older and what's younger. So here's an example I want to show you. So in this example, I have a whole bunch of different rock layers. So we want to examine, we want to list these from the oldest to the youngest. So my first law that I'm always going to kind of go to, this is kind of your go-to basic, is the law of superposition, where older is deeper. So looking here, I see some different things. I see layer I, layer B, and layer F. So layer I mean, if I was to look down here, I would probably see a layer I down below here. So these were formed, and then there was some type of event that occurred here, a shift or a slip. Maybe it was an earthquake or whatever. So there's a couple different laws that I'm looking at here. So using superposition and using cross-cutting, we can look at these. And so I'm going to say I is the oldest because it's the deepest. And then, I mean, even though F is above B over here, we know that there's probably an I underneath here as well. So we know that there was some kind of shift here. So we have I. We know I is older than B, and B is older than F. And then after that earthquake or whatever happened, it looks like layer M was built on top of that. And then on top of that, we see layer H here. And layer H, even though it exists all the way down here, we know that it was an intrusion that cut through all these other layers of rock. And so H has to be younger than M, F, B, and I. It has to be younger than anything that it cut through. So I'm going to put H next, and then that leaves us, it looks like H came through, maybe erupted onto the surface of M when M was the top layer, and then layer R was formed, maybe sediments blew onto there and formed a new rock formation on top of that. So then I would put R right there. So that's one example. I'm going to give you guys an assignment where you're going to have to use those principles to determine the relative ages of some rocks. And I hope you guys enjoy solving those problems. See ya.